We have a little dog called Rusty. It's a black toy poodle. When we take a walk in the evening in the dark, you can barely see him. So you can buy a light strip like this in a pet store, or you can program one yourself using MicroPython on an ESP8266 board. In this video we will talk about how to control an RGB LED strip with addressable LEDs and how to hook them up to an ESP8266 embedded microcontroller running MicroPython, not Arduino. The operating system I will use is Microsoft Windows. Let's look what we need for this project. We'll use an ESP8266, a LiPo battery 3.7 volts 3 amps. We need a neopixel digital RGB LED strip, and we'll put the components in this enclosure. It's a so-called soapbox. Let's take a closer look at the ESP8266 board. This is a Feather Hussar ESP8266 from Adafruit with stacking headers, so you can plug other wings to the board, such as the AdaLogger feather wing, including real-time clock and microSD card. For this project we need an ESP8266 without headers because it has to fit in the enclosure. The LiPo battery pack 3.7 volts 3 amps fits perfectly in the enclosure. The ESP board is placed on top of the battery. I forgot to mention we also need a micro switch to activate the program or to set into charging position. We will use two LED strips, one for the left side of the dog and one for the right side. The red wire goes to the positive 5 volt, the black wire to the ground and the green input wire to one of the GPIOs. The Feather Hussar ESP8266 from Adafruit comes pre-flashed with Lua-based firmware, so first of all we need to erase this firmware and flash MicroPython to the board. To do so, we connect the board to the computer using a USB data cable, not a charging cable, because we have to transfer data. Let's move over to the computer and start working from there. We need to find the number of the COM port we are connected to. Go to the device manager. Okay, I suppose you already have Python installed on your computer. Mine is version 3.8. And we'll also need a program named Putty. Putty is a software emulator for Windows. In the device manager, go to the COM port and you'll see the board is connected to COM16. Now we need to download the ESP8266 firmware from the site micropython.org. Go to the download section. Go to the generic ESP8266 module. Go to the stable firmware and download the latest build on your computer. The easiest way of programming ESP-based boards with MicroPython on a Windows machine is to use UPyCraft IDE, but there are other alternatives like for instance Tony IDE and AMPI. So first download UPyCraft to your computer. After downloading, open UPyCraft. Go to Tools and go to Burn Firmware. Select the board. Select the COM port. Select Erase Flash Yes. In the section Firmware Choose, select Users, and after pressing the Choose button, navigate to your download folder and select the ESP8266 bin file downloaded earlier. Having all the settings selected, hold down the Reset button on the ESP8266 board. While holding down the Reset button, click the OK button in the Burn Firmware window. When the Erase Flash process begins, release the Reset button. After a few seconds, the firmware will be flashed into the ESP8266 board. Reset the board once again and click the Connect button. Go to Device and let's look at the contents of the boot file. Here we uncomment the import ESP, the ESP.OSDebug, the import webREPL and the webREPL.start. Save and download the changes to the board so we can use the MicroPython webREPL page to access the board later. Now we have to configure the webREPL. I'll show you how to connect to the board using putty. First go to serial. Serial line is COM16 in my case. Change the speed to 115/200. Now we are connected to the board. Import webREPL setup and set a password. Now it's useful to be able to access the webREPL from other Wi-Fi networks and to upload code from a handy web interface. To do so, we need to run this set of commands here. In the WLAN connect line, enter your SSID and SSID password. The WLAN.ifconfig command will tell you the IP address of the board on the network. Now download the webREPL web page from this site and open it. Change the IP address to the earlier received IP address of the ESP8266. Click Connect. The password's name is Eddie. The Python prompt appears and we are connected to the board. From here we can upload and download files to the board. Go to Choose File. As an example, select the file named LED-test0. Click the button Send to Device. Let's check if the file is on the board. Run the command import OS and os.listdir. As you can see, the LED-test0 is listed in the file system. Now I saved the file named LED-test0 as main.py on my computer and send it to the board. The board will remember the wireless network it was connected to. If we power down the board and power back up, it's going to automatically reconnect and start the Python script. Let's take a closer look at the hardware. This connector is used to charge the battery. Here you can see how it's connected to the charging equipment. For charging the battery, you can use another ESP8266 and connect it to the 100 mA LiPoly charger connector. Or you can connect the battery to a charger booster board that outputs 5 volt at 1 amp. This is perfect to deliver a strong charge in a small amount of time. So I can fully charge the 3 amps LiPo battery in 3 hours. According to the current value settings of the LEDs in my program, we can make a 6 hours walk with a 3 amps battery.